Good morning or afternoon, depending on your time zone. This is Randall Ray from IC Bus, and I would like to welcome everyone to our Staying Connected series. We started this as a result of the coronavirus, but actually we really wanted to get our message out to our dealers and our customers and anybody that could benefit from hearing from us. Go next slide. We've had a number of these. Week we do this for people that have not been able to join us earlier. We have an open webinar and we've reviewed a number of topics. They're all available online. All of our past webinars are available online, as will be this one. And go ahead and hit this slide. Today we are going to be talking about the Power Solutions International, our propane engine that is used in the IC buses. They now are, we've had it for a little bit of while now. We're into the Gen II system, which has some significant updates and just an overall much nicer integration. And that's been in production for about 2 years now. Ryan Gallagher from PSI, the account manager, technical account manager, is going to take us through the details here. Alan Stegish, of course, is with us as well, the IC service director. You'll see a Q&A tab on your lower right hand of the screen. This is session 8. As you can see, we started a long time ago now, back in May, and we've added one. We initially started at 10. We've added one, Cummins cold weather updates. We'll be doing in October, and we're actually looking at what can extend beyond that as well. So next slide. I'd like to introduce Ryan Gallagher, who's going to take us through the 8.8 liter propane engine, Generation 2.
So, good afternoon, everybody. My name is Ryan Gallagher. I work with PSI. I'm here today to kind of take you guys through some of the ins and outs of our powertrain that's offered in the IC platform. Mainly going to be touching on our alternative fuels, which is liquid propane, and some of the similarities as well between propane and gasoline. So, as we all know, the market is slowly moving forward with propane. There's lots of incentives and infrastructures that are currently being built. They're growing every day. A big question to a lot of dealers, customers, and/or techs is why propane? I know there's a lot of concerns that have been expressed to me in the past about just general safety of propane. A lot of people are used to using diesels and gasolines, and when trying to get into propane, there are some more safety precautions that do need to take place. But as a general rule and statement is propane is very safe. The tanks on these are actually one of the strongest points on the bus. The structure of the tank, including the cage of the tank, and all components that are related to it as well. Propane itself, for purchasing it, we are a self-sustaining country when it does come to propane. Over 88% of the propane that you're using, that you're getting down the street or wherever your service station is, that's all coming from within the United States. And then that remaining 12% is still coming from within North America. The engine life, while running on propane, is drastically increased due to it being a clean fuel. Not only is propane about 104 octane, but it's a clean fuel that is keeping the internals of your engine cleaner and possible. This is a
hey Ryan, we're losing you a little bit. Are you on a microphone and it's getting a little distance from your mouth?
I'm just talking into the computer.
That's good now.
Okay, I'll just get closer to the screen.
Perfect. Thank you.
So the octane of the fuel, it's about 104 octane I'm sure most of you guys are familiar with gasoline octane ratings. You've got everything down from like 87 up to like 93, whereas propane is 104. Now that really just helps with reduce of NOx, but we're seeing a lot of bigger fleets that are heavy duty extreme operation vehicles such as taxis, buses, delivery fleet vehicles, things of that are moving to propane. And that is due to the increased longevity of the engine by running on this clean fuel. One other point here as well is the cost of propane. I'm sure everybody, when they go fill up their car, when they're going from week to week, when they're filling up their vehicle, the price is really never the same. It'll change numerous times throughout the day, and it'll fluctuate a lot week to week. It's strongly dependent on obviously oil prices, but the cost of propane is an extremely steady market out there. So it's a lot easier for dealers and customers or end users to project their total cost of what fuel is going to cost them on their predetermined routes and such. So kind of just reiterating what we just gone through a little bit there is the price. It's very standard. It's going to stay the same. It's not as volatile as other products that are mainly related to the oil prices. Parts and service for LPG and or our gasoline product. These are all readily available parts. We have since moved away, which I'll get into towards the end of this presentation, from a lot of the one-off LPG components that are in our fuel system, and as well as the cost of technicians to work on these buses, whether it's fixing them or it's just performing routine maintenance on them. If anybody or if any tech knows how to work on any light-duty internal combustion gasoline engine, they're not going to have an issue working on our LP system or gasoline system. That in turn, with lower maintenance costs, like I talked about before as well, with tax credits and grants, there's a lot of opportunities out there right now. I know specifically there's that VW grant out there, which is helping drive more and more customers to be looking at and entertaining moving to an alternative fuel engine. Also, the emissions of the engine, it's extremely clean. Even without any emissions components such as catalysts or anything like that, it's just in the nature of the fuel that it burns a lot cleaner than a gasoline or a diesel. Coming along with that as well is there's less in-bus noise. Noise is obviously a byproduct of an internal combustion engine, as well as vibration, which both are extremely reduced with the current system that we have, as well as it also being a low-speed engine. So with those higher RPMs, a higher RPM for us is going to be the same thing as a diesel. The max RPM is about the same, but we're not spinning the engine way up, which in turn is going to cause more vibration and noise. And then the byproduct, the CO and everything from the engines is a lot lower on the LPG specific engine. And then a lot of things that people don't take into account when it comes to emissions and going green and things like that is when you are filling up a typical liquid fuel like diesel or gasoline, when you're sticking the nozzle in your filler neck to fill the vehicle, there's a lot of vapors that are being released into the atmosphere. It's kind of that haze that you see if you're ever staring at the fuel pump as your vehicle's filling up. With LP, when you're filling these up, it's a sealed, controlled fill. So after you screw the nozzle on to your filling port, there's no exchange of vapors or anything that are going to be lost into the atmosphere when filling. So that's right there, off the cuff saving on your total emissions, while just fueling the vehicles with it not even running. So just taking a look at kind of how the different fuel options stack up to one another in regards to their emissions. Obviously, natural gas is going to be your cleanest, then you're going to propane, gasoline, and then diesel. Now, this is just the byproduct of those fuels, not taking into account any of your after treatment systems or your emission systems or things like that. You can already see for diesel or gasoline, it's going to be hard for them to compete with a propane emission standard, just bare bones as it is. They're going to have to put more and more emissions requirements and types of applications to clean up that byproduct of the engine running to even get to where propane is how it sits nowadays. So the infrastructure for LP is something that's continually growing throughout the United States. It's growing every day. Whether this is private stations or public filling stations, I know a lot of dealers and school districts are even putting in their own infrastructure where these buses are kept for fueling. This is something that it's becoming more and more popular throughout the United States. There's also apps available on your phone to help map out if you are taking an activity bus a few states away or something like that. You can map out these filling points, so you're not relying on tribal knowledge of where these filling stations are and if you're gonna make it there or not. You can map that stuff out ahead of time, and there's already apps that are created for that to kind of help the end user when filling up these. Kind of getting more into the propane safety as well. Liquid propane, typically depending on ambient air temperature, is going to live between 100 and 200 PSI. But as soon as LP is released or that pressure is no longer there, it's going to boil, in turn becoming a gas. LP, for those of you who don't know, boils at negative 44 degrees Fahrenheit. So what that means is anytime a tank is not under pressure, with the pressure, your boiling point obviously is lowered, or it's raised in the temperature range. But anytime the system is opened up, that vapor that you see is actually the liquid propane itself boiling off. Now, propane, there's additives put in it, so there is a smell to it. This isn't a smellless, tasteless gas. So when there is a leak, without even using a leak detector or bubble solution or something like that to find a leak, you'll be able to smell it. So that's another safety that's put in there so that it's noticeable whenever there is a leak. Propane is also heavier than air. So when a tank is released or there is a leak, that fuel is going to fall to the lowest point and it's going to accumulate there until it's blown away by wind or something like that. After it's dispersed, after it's mixed with oxygen in the air, it becomes inert. So there's no cause for alarm if this is getting released back into the atmosphere in the case of a leak or a rupture or anything like that. If there is a rupture in a line or there's a leak that is progressively becoming more and more somewhere in the fuel system, there are plenty of safeties put in place on every access point on the tank itself, whether that's the solenoids, your fuel lines, or your fuel fill hose. There's stops, there's check valves that are put in place in this tank to where if it senses an excessive amount of flow going through that specific port, there's a ball seat in there that'll snap shut and it'll close that. Now, the nice thing about that is if somebody forgets and they're servicing this unit or for some reason they had to remove a fuel line to get to some other component and they forget about that, it's not a one-time valve. As soon as that pressure is stabilized and the pressure on the front and back side of that valve equals out, that valve will automatically open back up and it'll resume operation like normal. All the Navistar tanks and the cages are all meeting all regulations and guidelines, whether that be rollover, front or rear impact collision. There's no more risk involved with running an LP unit than there is with any other type of fuel due to the precautions that have been taken and put in place for the safety of everybody involved. So as we we're kind of talking about pressures before, here's a little graph that you can see, kind of just put it into perspective. I would assume most of us are in summer right now. So right now your tanks are going to live between that 80 and 100 F range. So that's the numbers on the bottom here of the scale. That's ambient air. And then on the left is going to be your tank pressure. So between 80 and 100 degrees, that the inside of your tank is always going to be around, we'll say between 125 and 175 PSI. In the grand scheme of alternative fuels, that's not that high of pressures, even though that's higher than what you would really ever see in a gasoline or a diesel application. But you're not having to deal with CNG pressures, which are up in the thousands. We'll stick with LP here. So this is what your tank pressure is. It can vary depending on how much fuel you have in the tank at any given time. It's not going to fluctuate too much, but it can stray from this, give or take, we'll say 15 to 20 PSI. Now, this is just your tank pressure. On top of this pressure, you have two pumps in the tank, which I have images of and we can go through later on. But these pumps, one is a scavenge pump that's taking liquid propane from the back of the tank and it's throwing it into the front of the tank where your boost pump lives. This is for when you're grading, when fuel does slosh over the baffles that are already welded into these tanks, to make sure that your boost pump is always getting fed liquid propane, because this is a liquid run system. This is not run off vapor. So to keep liquid feeding our boost pump, we have the scavenge pump. That boost pump is then going to take our already tank pressure here, depending on how much fuel you have in your, and it's going to boost that, hence its name. It's going to boost that up about 40 to 50 PSI, and that's going to be going into your fuel supply line. Now that's going to increase your pressure so you have liquid all the way from the tank then to the back of your fuel injectors. It's going to be going through one more filter through your line into your rails and then sitting against the back of the injectors to where when the injectors cycle, you are squirting liquid propane, but obviously as soon as it is released into the back of the valves and your intake manifold in the head, then it's going to become a vapor and sucked into your cylinder where you're running. It's inherent in its design that it's already atomized, so you're going to get a nice even burn every time. So going into the NVH side of the PSI engine in the IC product, it's an extremely quiet engine. Now, I personally have driven a few of these buses. I'm behind the wheel of them pretty frequently, whether that's just idling in a parking lot or driving around a parking lot. The most noise that I personally hear in these units is the fan. When a fan kicks on, that's really all you're hearing. Other than that, I promise you, it reminds me of a sewing machine underneath the hood. It's an extremely quiet, smooth engine. You're not getting a ton of vibration and you're not getting a ton of noise. So for me personally, I do like louder vehicles, but after you sit in a loud car or a vehicle for an extended period of time, you are more drained, you are more tired. Whereas if you're in something a lot quieter and smoother, you still feel more refreshed, you still have more energy at the end of that 1 hour route or whatever it is. As well as the children that are going to be riding in these buses, they're not going to not talk to one another because it's so loud in a bus. They're just going to raise their voices and continue to do what they want to do, which is just going to snowball into the inside cabin of the school bus getting louder and louder and louder, which if I personally were a driver, I don't know if I would enjoy that. So an added benefit to the LP and gasoline is the vibration is significantly less, as well as the noise is significantly cut down. So with the gasoline and LP engines, the PSI 88, cold weather starts are really never an issue. We have gotten reports back of when we had a cold snap. I believe this was now 2 winters ago, and we were in the -20s in the northern part of the United States. The gasolines and LPs were firing right up as if they were unfazed. And another big concern with school buses is its idling time. Whether that's dropping kids off, waiting for kids at bus stops, or anything like that, it's inherent in what their duty is. There's a lot of idle time in these, and I know with diesels, with modern diesels and aftertreatment technology, idling is not a good thing. You're going to be clogging up your EGRs or your aftertreatment systems with that excessive idle time. And that's not a problem. They can be cleaned, but that's added cost and that's added downtime. Whereas with the LPG and the gasoline, it's the same as a vehicle. You can idle it really as long as you want to idle it. It's not going to hurt anything. If anything, it's just a little bit of a waste of fuel, but it's the same thing that you get with any other engine. Something to note when you are starting these buses or going through them, that's a little bit different, is there is a safety that's put in place on the fuel fill door. So if there is an instance where you get in the bus and you go to turn the key and you won't even hear the starter go, it's a no crank, no start, you will get a message on your instrument cluster saying the fuel door is ajar. Now what that is there's this sensor you can see on the bottom of the screen here in this image. It's a 2-contact point sensor, and what this is it's a proximity switch that senses this door being shut. That's just a safety that's put in place so that the fill neck of the LP system isn't exposed or open. Also, generally you shouldn't ever be driving around with your fuel door open anyways. This is another step that has been put in place to help somebody that's not used to the system, just to keep everybody safer. So going back to filling up these units, if you haven't seen a propane fill handle or nozzle before, this is what it looks like. It just looks like a gasoline or diesel fill pump from the future. There are 2 types of fill heads. You have your Euro style fill head, and then you also have your older Acme style fill head as well. Now these are things, depending on what station you go to, Euro style is the latest and greatest, but some stations don't always have that. Now for everybody to be able to feel comfortable and have the option of filling up at whatever station they want, this is something that can also be purchased with the unit directly from Navistar on these LPG units. You can have both fill nozzles, and it's just an adapter that screws onto the fill neck of the tank, and then you'd fill it up just like if it was the other style fitting. So no need to worry on if the station that you're going to has the correct style or not. You have that option available to you. Diving a little bit more into the cold weather operation, which is a big selling point for these engines, and some of the best feedback that we have gotten in the past on these engines. There is no winter front that's required on these. You're not having to cover up the front of these buses to get them up to operating temperature or anything like that. They have a typical run-of-the-mill thermostat that's going to be staying shut with LPG and or gasoline. Depending on obviously your temperature, it can take a little bit longer to warm up. But there's no reason you can't drive it while it is warming up. If depending on the temperature, when you do start the bus in a cold area or environment, it may cold idle, which is something that's completely normal. It'll idle about 100 RPM higher than if it were a warm start or a warmer day, and that's just to help get your operating temperature up faster so that you've got heat in the engine, so that you're going into closed loop for better emissions and fuel trims. and then just your cabin heat as well. Now, if you are wanting to warm up these buses beforehand, that's something that you can do. Like I mentioned, the idle time is not going to hurt anything, and you also have a idle ramp that is present on these buses from IC. Just by using your cruise control switches, you can fluctuate your idling RPM at a standstill from about 1,000 RPM up to 2,200 RPM to help reduce that warm-up time. That will not warm up a bus faster than just getting in it and driving it, because while these engines are under load, they will warm up a lot quicker. It's a way more efficient way of warming up, but I totally understand if someone doesn't want to jump in something freezing cold and then just get in there and go, they have that option. Now, underhood serviceability. Without getting too much into diagnostics or sensors or anything like that, just the pre-driving checks that I know a lot of districts and drivers do, such as checking your oil, your coolant, and your washer fluid, power steering, and transmission fluid. These are all checks that are extremely easy to do just by opening up the two latches on the hood. On the right side, which is the passenger side of the engine compartment, that you can see you have your freely available oil. Your coolant reservoir is right there in the front. It's really hard to miss, full of red coolant. Then your washer fluid is also mounted on the frame rail down there as well, so that it's all easily accessible and visible to anybody. Somebody doing a check like this does not have to be a technician. They can simply pop the hood and see all these components. And then on the driver's side, you have your power steering. That's just the canister. It's right mounted on the left side of the radiator housing. And then you've got your transmission dipsticks. That's being checked the same way as your engine oil. All of these checks are done without crawling behind or between the tire and the frame rail or having to crawl up on top of this. These are all easily reached just from standing on the ground after opening. Getting into the maintenance of these engines a little bit, this goes for gasoline and propane, is the oil in these engines that's used is a Dexos approved oil. That used to be something that used to be a newer standard a few years ago. Since then, if you do any of your own oil changes or anything like that, most motor oils now are Dexos approved. So this isn't confining you to a specific brand or anything like that. Now, when moving from summer to winter, the oil weight is going to stay the same. So you're not having to stock two different weights depending on what conditions or what season you're in. It's a year-round 530 that you can stock for the entire fleet. And that means as well, when you are going into colder months for units that may have just had an oil change, you don't have to go in there and change it to be able to get it into a lower weight for those colder months. It's all going to stay the same. As well as our coolant is also DexCool. This is a 50-50 mix. This is something that it's off-the-shelf coolant. Obviously, you always want to make sure you have your 50-50 mix if you are in colder climates or a climate where it does get colder, because you do not want your cooling system freezing, as in any engine. And then your oil change schedules are every 5,000 miles. Every year or once a year, you're just going to be checking your coolant quality and your freeze points. Also, you're going to be checking your fuel system. That's just crawling around underneath the bus, looking at your fuel lines, making sure there's no chafe points or you're not smelling any LP. And then obviously this goes the same for gasoline or diesel as well. You're going to be inspecting your FIAD, so that's your tensioners, your belts, your air intake pipe, and your clamps. That's every 15,000 miles. And then replacing external fuel filters every 70,000. On the LP, for example, the two pumps that are inside of the tank, which we'll see in a second, those pumps have sock filters on them. Those are lifetime filters, so you're not having to open up the tanks to replace fuel filters. The fuel filters that are being referred to here You have one on your fill neck, so that's filtering the fuel that's coming out of whatever your fill source is going into the tank. And then you have a second fuel filter that's going from your tank to your fuel rails, and that's your supply filter. Those are the 70,000 mile filters, and that is as easy as shutting off your two shutoff solenoids or valves on the tank, and then using a supplied gauge that can be purchased through Navistar. I'll show you the tool here in a minute, and releasing fuel line pressure, and then you just crack them loose. There's really nothing to it. And you can see here, the next one down, the fuel filters that are in the tank, that's for your scavenge pump and your boost pump. Those are lifetime filters. And then the rest of the stuff is pretty run-of-the-mill maintenance intervals for any type of internal combustion engine. Going into a little bit about the PSI engine and the powertrain itself. This is a really high-level overview. Just really want to touch on our key points on what this engine is. This isn't a repurposed GM 8.1 that was slightly gone through and threw in a heavy-duty extreme application. It is derived from a GM 8.1, but from the sump all the way to the top of the engine has been completely gone through and redesigned, and it is purpose-built for this application, for an extreme duty service bus engine. Now, what's different about this engine than what you'd see on any other V8, V10, or any other heavy-duty engine? The cylinder heads have been specifically designed by PSI for this application. Now, these are low-speed engines, so your ports in the engines, your valves, and your camshaft, it's all specific ground and flow rated for a high torque, low speed engine, which is exactly what this is. Your crankshaft and your pistons and your connecting rods, these are all forged internals. This is something you typically, if you hear of forged engines, this is something you'd see in like racing or really extreme applications. But for this heavy duty application, PSI went ahead and everything internal on this engine is capable of holding over 1,000 foot-pounds of torque. So the structure of the bottom end of this engine is extremely overbuilt for what it is, so that it can be reliable in these extreme applications. Now, the block itself, from provisions that have been added and anything like that, is actually 65 pounds heavier than the 8.1. Now, but since we are working with school buses, we don't really have to worry about weight. So adding material onto these is making it stronger, making it easier for it to dissipate heat. And in return, it's just increasing the longevity of the block and the engine itself. A little bit about PSI and why I believe personally IC decided to move forward with our engine platform is we are extremely and rapidly growing, and our technology is it's second to none. We are in-house designing all these components ourselves. So when we did go through the 8.8, that was all done in-house by our engineers. Our specialized machining, we have a building 101 that will take care of the base engine. So that's milling our blocks and our heads. So all of our milling and CNC machine work is all done in-house. So that's not something that's being sourced out, so that we can control all the quality and we can control all the specifications that are being put on to these 8.8s. We have extremely advanced engine manufacturing. That 101 building not only does the CNC machining on our heads and on our blocks, but they are also assembling the base engine. So that's everything from your oil pan all the way up to your intake manifold. They're putting in the pistons, the connecting rods, the crank, the heads, the valve springs. All of that is done in this environment. This entire building is a clean room because they are building open base engines. Moving on to more of like the powertrain assembly, these engines move. It's literally 2 buildings down the street to our next manufacturing plant, which is building 201. This is where they get their dress components, such as more of the exhaust. They're getting their exhaust manifolds, your ignition system, and your flywheel and your bell housing and things like that. That's all getting dressed in this building. Now, our testing and validation has come such a long way. We are, I would say, we're neck and neck with any major engine manufacturer when it comes to that. In 101, just the base engines after they're built are completely spun up manually by a cold test machine. This is checking that your oil system and your oil galleries are all clear and functioning properly, and oil's getting to the systems and components that they need to. This is checking crankcase pressures, as well as cooling system cavities and pressures. Now in 201, after the engine is fully assembled, it's put into a hot test where the engine actually is being run underneath its own power for about 10 to 15 minutes. And this is making sure that all cylinders are firing, all sensors are doing what they're supposed to, it's meeting emissions requirements, and it'll get up to operating temperature and then be shut down. And this isn't just something that happens for 1 out of every 5 or 10 engines. Every single engine goes through that process. Application engineering. We do have a few school buses on site as well for testing and validating, ever improving parts and components on these as well. And our software, our calibrations are all controlled and made and programmed in-house. And we do our own dyno testing for EPA certification as well. So this is something that's not very standard for an engine manufacturer to be an all-in-one. But since we are, that means we're really quick to respond and to change with the ever-changing market when it does come to these. So a little bit of an overview of the 8.8 liter itself from a statistical standpoint. It's a 535 8.8 liter engine. You're running a pretty standard 10-to-1 compression ratio. It might seem a little bit high, but if you remember back, the LP on these is running, it's 104 octane, so you don't have to worry about knock or anything like that with a higher compression ratio under a really high torque, low speed engine. These are rated at 270 horsepower and about 565 foot-pounds of torque. It's almost identical to what you'd see on an ISB or a Cummins. So as you can see here, we've got the ISB and the 8.8 next to each other, just because not trying to displace any of that, but so you can get a comparison, because most of the market is full or saturated with Cummins engines. That's what the majority was in the past. So all drivers, districts, and things like that, whoever's using these or around these buses all day, every day, it's kind of what they know and how they operate. From a driving standpoint, the only difference that you would really see with this is that NVH, that noise and vibration, or any type of harsh driving experience that you would get as a standard byproduct of a diesel. It's really eliminated when going to that LPG or that gas. So looking at this here, comparing it to a few other competitors that are in the market as well, you can see if you look at horsepower figures at an RPM range of, the high of the RPM range is 2400 RPM, you're right there on horsepower as well as torque. And that bore and the stroke of the piston itself, which gives you the standard driving characteristics, matches, is extremely similar to that of the Cummins. Sorry, I'm trying to speed up a little bit here. I think I'm running a little bit behind for the time frame that we have, so I'm gonna kind of speed this up a little bit. In return, with the low speed engine itself, we are approved and we are able to run the tried and true Allison transmission, which is a huge benefit to any end user. I know everybody loves that transmission, and that's something that we're able to use and adapt to our engine because of those driving characteristics and the way the engine was built and calibrated to where it matches the same spinning speed as that of an ISB. The base engine of ours is extremely simple. Simple is it's something that a lot of the industry and auto manufacturers is kind of moving away from. Everybody's getting more and more tech, and tech necessarily it's cool. It's a good thing. You can help out a lot with things, but as far as a longevity standpoint, durability, and maintenance, simple is a good thing. Our camshaft isn't just the camshaft. It runs your oil pump as well, which is something that engines have been doing for an extremely long time. This is a cam. It's a single cam engine. It sits in the valley of the engine, so both banks are run off of one cam. And in return, what that means is you have one timing chain. And as you can see, the timing chain is extremely small. It runs from a crank sprocket, and it drives your cam directly. As far as timing, you're only lining up 2 timing marks. You can't put the chain or the gear on the wrong way. Both are dialed and or keywayed, and there are no guides to wear out. Whereas a lot of dual overhead cam or single overhead cam engines, the chain's so long they have to have tensioners on them so that they don't skip time. Whereas the simple, proven, old school system, that's really kind of where it pulls away from that. The engine block itself, as I said before, is about 65 pounds heavier of that than the GM 81. We have piston cooling nozzles, which there's an image of a little bit further on, and we have 4-bolt main caps as opposed to a 2-bolt. That just helps with distribute your clamping force more evenly for those severe applications. As you can see here, this extremely tiny little nozzle in the crankcase, that's an oil squirter. That shoots oil on the bottom of your piston, evenly coating your cylinder walls so that there's always that fine layer of oil between your piston rings and your cylinder wall itself. So that helps extremely with longevity. You're not getting any metal to metal contact. And this is technology that was primarily originally used for diesel applications, which has now since been adopted for continuous improvement on this as well. Here you can see some images of the forged crank and our forged connecting rods. They're extremely stout. We're using them to about half of their capability as far as power rating wise. All of our engines, not just LPG, but also gasoline, come with an oil cooler. This helps keep your oil cool, your engine running happy in those extreme conditions. This is something that most gasoline engines or light duty engines don't have from the factory. But since this is for this specific application, this is standard on every engine. So I know a big talking point when moving from a diesel to any type of other type of fuel system is the emission systems that are always getting more and more strict. Well, I've got great news for everybody. It's staying the same as far as what you'd see on any normal internal combustion gasoline engine. The emission systems for a gasoline or an LPG are identical. You have 4 oxygen sensors, 2 on each bank, 1 upstream and 1 downstream of the catalyst. On each bank, there's 1 catalyst. After that, that's it. That's your entire emission system on these engines. That's for LP. When you do get into the gasoline, you do have to have a charcoal canister, but nor our gasoline nor LPG have an EGR, which is an exhaust gas recirculator, so you don't have to worry about that clogging up with any type of carbon or anything on a gasoline product. That's eliminated. We are able to hit our emissions requirements and figures with this extremely simple system. The oxygen sensors that we use, these are off-the-shelf oxygen sensors. This isn't something that is specialized to PSI product. This is a Bosch oxygen sensor. So these are readily available. They are mass-produced, in turn helping the customer and the end user with cost and availability. Our catalysts, they are all the same from LPG to gasoline. They all have their own heat shields on them, and there is, as much as I'd want to say there's something special about them, it's a normal run-of-the-mill cat. Placement and sizing, and it's able to make and or exceed any type of emission requirements just by that. Now, flying through the diagnostic tools a little bit, because this is a cost that an end user or a dealership or a school district would run into. For our gasoline and LPG product, you are using a OBD-HD connector. It's a standard style green. I believe it's a 6-pin connector. This is the same thing that you're using already on your Cummins engines or any of your diesels. Any heavy duty product is using this cable. This isn't something that PSI took and made our own diagnostic software or anything like that. We use PowerLink, which is something that's also used on an ISP, and our connector head is the same. Going more a little bit into diagnostic tools, you've got a spark plug wire puller, you've got a spark tester, and a Noid light for checking to see if an injector is firing. Make sure there's not a blown fuse or something in the instance that you do run into any type of misfire. Other standard tools, which are not just special to a PSI engine, is a compression tester and a cylinder leak down tester. These are just basic diagnostic tools. Some tools that might look a little bit new is a sniffer, the one on the top left. That's to help find or pinpoint any type of leak in an LP system that might be so small that you can't smell it, or it's not leaking enough for you to hear or smell it, but this will pick it up. Also, there's a 3 switch box. This is so that you can power those individually to check amperage draw and operation. And then the nozzle to the right, this is an adapter piece for the fuel fill in the instance that you do have to drain it in some type of manner. Here is your fuel pressure gauge. This is gold when coming to diagnosing and or working on or servicing LP units. This is the tool that you're going to use to drain those lines. You do have to replace those filters every 70,000 miles. This connects to a Schrader valve, which is right on top of the engine. You hook that up after closing your 2 thumb screws on the tank, and you're ready to go. This hose is very long. That's so you can vent it out outside of the shop or wherever a designated area is to dump those vapors that are just in the lines. Here's a propane evacuation unit. This will pull vapor and liquid out of a tank. This is for if you are having to service or get into any type of propane tank. This is the tool that you use. This tool, just like the tanks itself, all of these ports, I know it looks like a lot, but they all have safeties built into them. There's really great instructions that obviously come with these, but working with this system, it's simple if you just follow the lines and you actually like look at it. It's a simple system, and it's user friendly, even though it might not look like that at first glance. I promise you it is. Here, this is a propane flare-off tool. If you are in an area that is not restricted, you can flare off propane. And just to give you a little bit of a background, I'll go over it really quick. The image that you're seeing on the top right is an LPDM. This is what our Gen 1 systems had, just so you can know some of the improvements that you've made if you're not already familiar with our product. This is what was standard on all of our Gen 1 systems. It was a great product. It was tried and true. It worked. But obviously, there's always room for improvement. So we moved to this system. This is an extremely simplified version of it. But that big piece that you saw on the top right of the screen has since been replaced with these 2 solenoids that you can see in the center to right side of the screen, the ones that the blue dotted line and red dotted line are going to. that took the place of your LPDM. So to follow the system through a little bit, you have your fuel pump. You've got two in there. You've got a scavenge pump and your boost pump. We'll say this one's the boost pump. It's going to supply your supply valve or your supply solenoid. Then it's going to go through that filter that we were talking about, that 70,000 mile maintenance interval. And it's going to go through a fuel line all the way up to your fuel distribution block. This piece that's in the middle of the screen lives on top of your vanity cover. So to get to this piece, it's as easy as checking your engine oil as well. You just pop the hood and it's right there. What this piece does or serves a purpose for is it holds your pressure and temperature sensor. This tells your ECU what your fuel pressure is. If we've got it up to operating pressure, this is what's going to tell your wait to start lamp to turn on or off when cycling the key. Next to that is your Schrader valve. This is how you determine what your fuel line and or rail pressures are. And if your boost pump is up to snuff and it's working correctly, this is where you would check to see what pressure are you getting here over what's in the tank. And that differential is going to be your boost pressure. Here it goes into two hard lines. These two hard lines are coaxial lines. What that means is your fuel supply and return goes through that one single line. This helps with packaging as well. So you're not having to go into both sides of the fuel rail. You're able to go in through one side, feed the rail, and the other side of the rail, barely see, that's going to be a return spring. It'll allow the fuel around back through the line, and it'll then go to your return line and back into the tank. So this is a recirculating system. Here, this is a closer version or a view of your solenoids. Your supply and return are the same. That's something that, once again, helps out the end user. You're not having to stock two different parts for any type of future failure or something that you may have. When you order a part, it's going to be the same, no matter if you're working on supply or return, or if you just felt better or more comfortable stocking these, it's the same part number, which is great. These are off-the-shelf Rotor X valves. These are tried and true valves. This isn't something that's specialized to PSI. So like I was saying before with our oxygen sensors and Bosch electrical components, is these are high volume and in return helps with cost as well. Now, some of the stuff that's different between Gen 1 and Gen 2 and some improvements that we've made is, one, it eliminates LPDM. You have new fuel pumps, and then you've got your external filters in the junction block. Just to keep going quickly here, we've got a few more minutes. I hope I'm not boring much. Here's an external image of a Gen 2 tank. Now, without knowing what Gen 1 looks like, you wouldn't really notice any of the differences. But something I want you guys to take note of is your pump locations you can see in this transparent view. The left side of this is the front of the tank. The pumpkin or the differential will live right in front of this. And the back of it, that second pump that you see back there, right behind that's going to be your back bumper area. So you can kind of put it into perspective a little bit. The back pump is your scavenge pump. That's sending liquid propane up to this cavity in front of the baffle in the front of the tank to always supply that boost pump with liquid propane. Here on the front of the tank, this is what you see if you're underneath the bus. This filter that you see right here, this is your supply line filter with the feed rails. This filter and your other filling filter that goes from the filler neck, that's the same part number as well. So it's another instance of stocking one part for your service and your maintenance intervals. You have your two Rotor X valves. Those live right on the front of the tank, and that screw that you see on top, it's referred to as a thumb screw. This is where you can manually shut off the flow of fuel from the tank to the line. If you are ever servicing them, that's where you can do that. Now, that is a safety. Like I said before, if somebody cracked, we'll say they wanted to replace this filter and they cracked that line, but they forgot to shut that valve off. There's a manual check valve right in that valve that's going to separate tank pressure and atmospheric pressure once that line is cracked. That's a prime example of a safety that's already put in place in the system. It makes it more user-friendly. Here's a side-by-side of Gen 1 and Gen 2. Gen 1, you've got the big LPDM in the front. And that's your only access point. Whereas on Gen 2, you've got Rotor X valves, you've got your fuel filter to help with filtering any type of debris or welding slag. that is a byproduct of creating these tanks. And then on the bottom of the tank, you have 2 access plates, whereas before you did not. You were accessing a boost pump and a scavenge pump. Before, the scavenge pump was more or less using a straw to get to the back of the tank, whereas now it lives in the back of the tank. This helps with supplying fuel more. It's more standard. Whereas if it's sloshing around or something like that, going through a straw size orifice versus a big sock filter, it's sitting on the bottom of the tank, it's a lot more effective. To get to both of those pumps, you now have individual access plates. So in the instance that you do have to get into these tanks, you can easily reach both of them by these access plates. For me personally, this was huge from Gen 1 to Gen 2. Your fuel level sender, that's going to be standard from Gen 1 to Gen 2. The improvement that was made on that, I'll get into in a little bit, is the material of that float. Here's a little bit closer of a view of what's going on in the tank. On the left, you've got your Gen 1. There's a cup filter in there. This looks like a canister style filter that you'd see on a car's oil filter. Now, before, that's not something that's easily changed. You've got a whole tank and get in there and do all of that. But you've got your scavenge pump sucking, like using that straw from the back of the tank. Whereas now we've got our Coavis pump. It's the same from the back to the front. So scavenge and boost pump, same part, same function, just connected differently. They both use a 2-wire connector electrically, but as far as moving fuel from one area to another, that's the only thing that sets them apart from one another. And as well as the filters, the sock filters, you can kind of see the little white square on the bottom of the right image. That's your sock filter, and both of these have them on there, and those are lifetime filters, so there's really no need to ever get in here and replace and or look at that. Here you can see, like I said, your LPDM is replaced by those 2 Rotorex valves. Once again, same part number, same exact part. Before, your scavenge pump and your boost pump were different parts. They look completely different. Whereas now, your Coavis pump, that one is the exact same thing, just ×2 for your boost and scavenge. On top of the engine, like I said, when you pop the hood, this is what you're seeing. This is the vanity plate. This is on intake manifold. There's nothing obstructing this. Once you get underneath here, you have access to that Schrader valve, fuel pressure temperature sensor, supply, return, and your coaxial lines in the event that you ever do need to remove or get to that. They're all readily available. Before, you had 2 lines, one serve tank 1, one serve tank 2, and from the engine all the way to the tank, that was one coaxial line. Cool, great technology, but extremely costly to have that one specialized line that's made in-house reach however long the bus is, depending on the spec. It's a lot of cost and a lot of time, whereas now we're using off-the-shelf LP-approved hosing that it goes one way in the hose. We still keep that coaxial technology, but in a much smaller confined area to where you're not having to service that. And that's not a high-risk area because you're not running 20 feet down the side of a drive shaft or anything like that. So that's one of our great biggest improvements. And then lastly, before I turn you back over, is the fittings on these fuel lines. I know for anyone that had ever worked on these in the past, it was pretty hard to get this Gen 1 fitting that you see on the left side of this image to screw into either the LPDM or the fuel rail. This is a fine thread aluminum fitting. If you tie that with a 90-degree angle right on the end, it doesn't make for a fun time trying to reconnect that junction. Whereas now with the standard LP hose, this is just a regular LP approved hose, and it's a cut fitting. These threads, it's extremely easy to get them started, and you don't have any weird twists or bends right at that connection point, making it harder on whoever is servicing the unit. So our servicing costs, our maintenance costs, maintenance intervals, and just part costs have all gone down within the recent past to this Gen 2 system. So I just wanted to talk with you guys today, kind of make sure everyone is aware of the technology that's out there, because this is, as much as we want to say it's cutting edge stuff, the components that we're using are components that are being used in any type of LP system, whether it's a a stationary outside your house LP tank above ground, or it's in a bus. All these components are extremely similar and the same to one another in a lot of ways, which helps the end user and servicing these just for you. So I appreciate your guys' time. I'm going to turn you back over to Randall.
Do we have any questions out
Got
there?
it. No, I don't see any questions coming in. Alan, you want to wrap us up there?
Yeah, let's go through a couple things. First of all, obviously, Brian, thank you so much for the support today, putting together the presentation of the call. A great presentation about propane, principles about propane, safety, and certainly Gen 2 updates. So thank you once again. As always, I always end up with the monkey slide for some reason here, but we do send out surveys, and you know, we can get one way we can get better is from your comments. So if you like the presentations, obviously we will continue. This is session 8. There's 3 more on this line, and if there's something that you think we would be want to add to the program, please do. Send us in your survey. Give us some ideas. And once again, thank everyone for being on the call. Thank Brian for putting together the presentation, and have a good day.
Great, everyone.